And we're now recording. All right, we're almost done, folks. So you should have gotten your exam 5 scores. And I sent a video of which I messed up. What else is new? I adjusted it and we'll go over all of those. Okay, so I will do a rapid run through of the previous exams, and you can use this video as, actually, let me check something, sorry. Yeah, I want to make sure that we're recording there. So yes, we are. Okay, so questions and answers. I'll let you ask questions on previous exams if you wish, but I'm basically going to go over all of them. And there's the final exam, and then we're finished. Okay, so just like the previous 3 exams, you have the entire class period. So maybe a couple minutes before class starts, I'll send the exam via Canvas announcements, and you have the entire time to do it. So 6:10 to 8:25. One main difference is you don't have to submit any homework this time. You may have 5 cheat sheets. You can have the cheat sheets from all the previous exams. If you want to update it, you're allowed to do that. Okay, and to study, just study the old exams. In fact, you can probably survive just watching today's video, because today's video, I'm just going to go through the previous exams. So most likely scenario is something like I'll take 3 questions from every exam. I'll look at the first test, pick 3, second test, pick 3, and so on. So that'll lead us to 15 questions for the final exam. They don't have to be the very same questions, but they could be. If I don't feel like making new ones, then I won't, but otherwise be ready for that. Okay, so we are pretty much done with this. We don't need to look at this anymore. You don't need the homework anymore. So here's our homework sheet. It's unnecessary. Matter of fact, you don't even need the book anymore. So you don't have to look at the book, just look at the old exams. In fact, you can just look at the videos, of which I've already sent. So you should still be able to find all the exams and all the exam solutions. But just to make things easier on you, I'm going to go ahead and rapidly run through all of them anyway. And that's pretty much the game plan for today. Okay. So I'll do a rapid run through. Now I am going to go fast. Okay. And I think I am justified in doing that. First of all, you've seen all of this before. Okay. It's all something, it should not be new. You've all looked at all of the exams quite intensely. Let me put down the book, it's heavy. Okay, so you've looked at these intently, and it's not like I'm lecturing on it the first time. So you've seen all of this before. So I will be going somewhat rapidly. If you want to slow me down and ask a question later, you may, but I don't think it's necessary. It shouldn't be, again, of the type, I've never seen this before. You saw all of this on the previous exams. I'm just running through them somewhat quickly. And then, of course, since they are recorded, you can always play back. You can pause, fast forward, rewind, look back as much as you want between now and the final exam on Thursday. Okay. And let's see, right, Elliot, I got you here. Well, I'll get you later. I put away my roll sheet. So that's what's happening. So any general questions before we go ahead and start? What's happening? Okay, Jerry. Okay, got you. All right, so I'm just going to go test by test. And yeah, you can survive just by looking off the video. All right, so I will show all the questions quickly, and you can ignore my notes on the right-hand side. That's just my quickie solutions, but I'll go over them in detail. And I can't quite show the entire page. Maybe I'll do this. Okay, here's the entire left side, and now here's the entire right side. Again, you should theoretically be able to find all of this that's there. Okay. Okay, so number 1, a sphere centered at -316, passing through 4, 1, -4 means the radius is the distance from this point to this point. So it's square root of 4 minus a -3 squared plus 1 minus 1 squared plus -4 minus 6 squared. That comes out to be 7 squared plus 0 squared plus -10 squared, radical 149. So x plus 3 squared plus y minus 1 squared plus z minus 6 squared equals 149. Number 2, to find a unit vector in the same direction, just take the vector and divide it by its magnitude. So -8, 1, -6 divided by the square root of -8 squared plus 1 squared plus -6 squared. That comes out to be radical 101. So -8, 1, -6 divided by radical 101. Okay, number 3, find the angle between the vectors. So cosine of theta is a dot b over magnitude A, magnitude B. -4 plus 0 plus 6 divided by square root of magnitude of A, 1 squared plus -3 squared plus 2 squared, square root of -4 squared plus 0 squared plus 3 squared, 2 over radical 14, radical 25, 2 over 5 radical 14. That's cosine of theta. And use inverse cosine button on your calculator. Theta, closest angle is 84 degrees. Number 4, direction cosines and direction angles. So unit vector is -7, -3, 9 over square root of -7 squared, 49, plus -3 squared, 9, plus 9 squared, 81, radical 139. Okay, so the direction cosines are just -7 divided by radical 139. Cosine alpha is -7 over radical 139. Cosine beta is -3 over radical 139, and cosine gamma is 9 over radical 139. Punch in your calculator to the nearest degree. Alpha, beta, and gamma in order are 126 degrees, 105 degrees, and 40 degrees. Okay, number 5, scalar and vector projections of B onto A. So B is 1, 1, 1, A is 4, 2, 0. Scalar is comp of B in the direction of A is A dot B over magnitude of A. So dot product is 4 plus 2 plus 0 over magnitude of A is the square root of 4 squared, 16, plus 2 squared is 4 plus 0, 6 over radical 20, 6 over 2 radical 5, or 3 radical 5. Vector projection, proj of B in the direction of A is A dot B over magnitude of A times a unit vector in the same direction as A. So I just take the answer that I got for here, 3 over radical 5, and multiply it by a unit vector in the direction of A, 4, 2, 0 over radical 20. That comes out to be 3/10 of 4, 2, 0, 1.2, 0.6, and 0. Okay, number 6, find the area of the triangle determined by these 3 points. So I find the vector PQ is 1, 1, 1. PR is 4, 3, 7. Take the cross product, which is IJK 1, 1, 1, 4, 3, 7. I component is 7 minus 3. J component is the opposite of 7 minus 4. K component is 3 minus 4. 4, -3, -1. So the area of the triangle is 1/2 of the magnitude of 4, -3, -1. 1/2 the square root of 16 plus 9 plus 1. So radical 26 over 2. Okay, number 7. You're going from 2, -1, 3 to 4, -2, 4. So the direction vector is 2, -1, 7. So use the formula R is R0 plus TV. 2, -1, 3 plus T times 2, -1, 7. X is 2 plus 2T. Y is -1 minus T. Z is 3 minus 7T. Solve for T. T is X minus 2 over 2 equals Y plus 1 over -1 equals Z minus 3 over -7. So parametric equations, symmetric equations. Okay, 8, you're given a point and a normal vector. So just take the dot product and you get 0. So -1, X plus 2 minus 3, Y plus 4 plus 2, Z minus 1 is equal to 0. You can leave it like that, actually. You know, the rest is just heavy duty algebra, which we've all passed. But you can do the algebra if you want. X plus 3Y minus 2Z plus 16 equals 0. Okay, number 9. V1 is -6, 9, -3. V2 is 2, -3, 2. They are not scalar multiples of each other, which means they're not parallel. Okay, and to see if they intersect, so I set the Z's equal to each other. So I get -3T equals 2S, S equals -3/2 T. I plug into line 2, X is 1 plus 2 times S, -3/2 T, which is 1 minus 3T, and that's equal to -6T. 3T is -1, T is -1/3. Plug in, S is equal to -3/2 times T, or 1/2. But if I try to plug in for Y, I get a contradiction. Okay, since Y is 1 plus 9T, then Y is 1 plus 9T would be -2. But if I plug into Y for the other equation, 4 minus 3S, and plug in for S, I don't get -2. So that's a contradiction. So that means the lines are skewed. Okay, 10, the traces for z equals y squared minus x squared. X equals 0, the yz plane. By convention, whenever z is involved, z is going up. Plug in 0, z equals y squared, parabola opening up as far as the yz plane is concerned. Y equals 0 is the xz plane. Z again is always up. Z is negative x squared, parabola opening down. Z equals 0 is the xy plane. Well, we've been doing that for a long time. 0 equals y squared minus x squared equals y squared, y equals plus or minus x. So two lines that look like that. Okay, and so that's the end of test number 1. And I'll do my focus thing as I normally do. So 4, 5, 6. And yes, I'm going fast, but you can always look at the video and rewind and fast forward and pause as much as you want. 8, 9, and 10. And remember, theoretically, you already have all these videos from before. Okay, 1 test down, 4 to go. Let me check the chat. Okay, Rashan got you, Carl got you, Nicholas Trapanis got you, Amy got you. And let's see. The notes updated. Yeah, theoretically, I already made the updated things. Oh, and by the way, anybody on the test, well, you should be pleasantly surprised. You should never be unpleasantly surprised. So some of you made the same mistake as I made on the previous, on the last exam and the previous exam. So if you make the same mistake as I made, I won't dock you for that. So you always get 10 points for it. So my policy, so for the previous exams also, when I make my answer key and I mess up, okay, if you got the exact same answer as I did, I'm going to give you full credit. So let's say the answer was supposed to be, I'll pick easy. The answer is supposed to be 12. I came up with 10. I will accept as full credit either 10 or 12. Okay, because I messed up. I did a wrong step and I got 10. So since you made the same mistake as I made and I messed up, then so if I ever mess up, if you get the same mess up as I did, you get full credit. But if you got the correct answer, you still get full credit. So some of you might be wondering, how did I get full credit? It's because you made the exact same mistake as I did. So in other words, whenever I mess up, you got 2 chances to get full credit. That's if you wrote the same thing as I did, you made the same mistake as I did, or you actually got the correct result. Okay, so that is that. Okay, test number 2. Okay, and yeah, let me do this. Let me just run down the left. I think it's easier that way. And I run down the right. Ignore my notes over there. Okay. So number 1, for the domain, t can be any real number there. There, t plus 1 has to be greater than or equal to 0, and 5 minus t has to be greater than or equal to 0. And I don't accept it if you just go straight to the answer. You need to show me some work. So I did not accept just this. You can't just say, oh, it's obvious. I don't accept that. It's not that obvious. So you should show me this. T is greater than or equal to -1, and t is less than or equal to 5, so the domain is -1, 5. Okay, number 2. The only thing in question is the second one. Here you just plug in, here you just plug in. Here you probably want to do L'Hopital's rule. So for the y component, limit as t approaches 1 of 1 minus t over t plus 1, t minus 1. These two guys cancel out to give me -1. So limit as t approaches 1 of -1 over t plus 1 is -1/2. So radical 2, -1/2, cosine 1. Number 3, x is e to the -t or 1 over e to the t. Y is e to the t. That means x is 1 over y or y equals 1 over x. You're in quadrant 1 only. Okay, everything has to be positive. So it looks like so. T equals 0, you're at 1, 1. And then which direction does it go? I plugged in t as 1. That gives me 1 over e. So that means we're going this way. And here's the vector r prime, and here's the vector r. Remember, the vector r always emanates from the origin. There's the vector 1, 1 right over here. Okay. And then for r prime, it's negative e to the negative t, e to the t, plug in 0, -1, 1. So the tangent vector is this way, -1, 1. Number 4, unit tangent vector. R prime is 4, 3 cosine t, negative 2 sine t. Plug in pi over 6. Cosine of pi over 6, radical 3 over 2. Sine of pi over 6 is 1/2. 4, 3 radical 3 over 2, negative 1. So the unit tangent vector is 4, 3 radical 3 over 2, negative 1, divided by the magnitude of that vector, which is 4 squared 16, 3 radical 3 over 2 squared is 27 over 4, plus negative 1 squared is 1. Okay, this comes out to be 95 over 4. If you multiply top and bottom by 2, remember square root of 4 is 2, it gets a little bit nicer. So 8, 2 radical 3, negative 2 all over radical 95. Okay, number 5, basically just 3 integration problems. So the integral of the first one is sine of 2t, second one is 1/2 cosine 2t, and the last one is negative t cosine t plus sine of t. That one was integration by parts, so a little timeout for the z component. Remember integration by parts from Calc 2, let u be t, dv is sine t dt, du equals dt, v is negative cosine t. So the integral is uv, negative t cosine t, plus the integral of v du. It's minus a minus, so it's positive integral of cosine, which becomes sine. So negative t cosine t plus sine t plus c. So that's what get plugged in here. Okay, plug in 0. Let's see. Okay, plug in 0, that's 0. That's not 0. That's going to be 1. And that's going to be 0. So plug in pi over 3, sine of pi over 3 minus sine of 0. 1/2 cosine pi over 3 minus cosine 0. And negative pi over 6 cosine pi over 6 plus sine pi over 6 minus 0 minus 0. Okay, so this comes out to be radical 3 over 2. And that comes out to be 1/4 minus 1/2. And that's negative pi over 6 times radical 3 over 2 plus 1/2. So radical 3 over 2, negative 1/4, negative pi over pi radical 3 plus 6 divided by 12. Okay, 6, finding the length of the curve. So it's the square root of dx dt squared, radical 2 squared, plus dy dt squared, e to the t squared, plus dz dt squared, negative e to negative t squared. That's 2 plus e to 2t plus e to negative 2t. This very conveniently is e to the t plus e to negative t squared. So the square root is e to the t plus e to negative t, whose integral is e to the t minus e to the negative t from 0 to 1. Plug in 0, you get 0 in the form of 1 minus 1. Plug in 1, you have e minus e to the negative 1, or e minus 1 over e. Okay, so that's it for that side. Let me do my focus thing. That. And all that. 6, okay. Okay, 7. Yeah, that was kind of a tricky one. Okay, so r prime is t squared 2t2. Unit tangent vector is t squared 2t2 divided by magnitude, which is the square root of t to the 4th plus 4t squared plus 4, which very conveniently is t squared plus 2 squared. Square root of that is t squared plus 2. Okay. Now to find t prime, okay, this one, it's easier to think of it as t squared plus 2 minus 2 on the numerator. That way it's 1 minus 2 t squared plus 2 to the negative 1. This is 2 t times t squared plus 2 to the negative 1. So the derivative of this is the opposite of the derivative of this. Okay, the middle one I'll just leave. That one will have to be the quotient root. So dx dt, it turns out to be 2 times t squared plus 2 to the negative 2 times 2t, 4t over t squared plus 2 squared. Okay, so that means I automatically know that dz dt is its opposite, negative 4t over t squared plus 2 squared. dy dt, product root, quotient root, bottom times derivative of the top, t squared plus 2 times 2, minus the top times derivative of the bottom, 2t times 2t, over the square of the denominator. Clean it up, 4 minus 2t squared over t squared plus 2 squared. Okay, so the derivative comes out to be this, okay? Remember, if you're trying to find a unit normal vector, you can multiply by any scalar multiple of this, which means I can just lose the denominator if you want. Okay, so just throw out the denominator. Okay, you get the same unit normal. Okay, so I can use this. And yeah, in retrospect, I could have even factored out a 2. That might have been even easier, but anyway. So the unit normal vector is this thing divided by square root of 16t squared plus this thing squared is 16 minus 16t squared plus 4t to the fourth plus this thing squared 16t to the fourth. This comes out to be 4t to the fourth plus 16t squared plus 16, which very conveniently is 2t squared plus 4 squared. Okay, so I have this, and then just divide out the 2. Divide 2, 2, 2, take out a 2. Final answer 2t, 2 minus t squared negative 2t over t squared plus 2. 8, here's the original r. R prime is negative sine t cosine t. R double prime, negative cosine t minus sine t. Cross product is ijk, negative sine t cosine t, negative cosine t, negative sine t. So the I component is sine squared minus a minus cosine squared, which is 1. J component is the opposite of sine squared minus a minus cosine squared, so negative 1. K component is sine cosine minus sine cosine, which is 0. Okay, so the curvature kappa is the magnitude of the cross product, 1, negative 1, 0, divided by the square root of sine squared t plus cosine squared t plus cosine squared t cubed. This comes out to be radical 2. So radical 2 divided by 1, sine squared plus cosine squared is 1. So radical 2 over 1 plus sine squared t to the 3/2 power. Okay, 9, here's the original function. So v is the first derivative, 1, 2t, 3t squared, plug in 2, 1, 4, 12. Acceleration, second derivative, 0, 2, 6t, plug in 2, a 0 to 12. Speed is the square root of 1 squared plus 4 squared plus 9 squared. Comes out to be radical 161. And finally 10, r prime is negative sine t cosine t 1, double prime, negative cosine t, negative sine t 0. Dot product is sine t cosine t minus sine t cosine t plus 0, which is 0. Cross product ijk, negative sine t cosine t 1, negative cosine t, negative sine t 0. So the I component is nothing minus a minus sign, so sine. J component is the opposite of nothing minus a minus cosine. K component is sine squared minus a minus cosine squared 1. And what is the magnitude of that cross product? Square root of sine squared of t plus cosine squared of t plus 1, 1 plus 1, square root of 2. So in other words, the magnitude, and also the magnitude of r prime is the square root of sine squared t plus cosine squared t plus 1. Okay, it's the magnitude of this, which is also radical 2. Okay, so therefore the tangential component, a sub t, is 0 over radical 2, which is 0. Normal component, radical 2 over radical 2, which is 1. Okay, so that was test number 2. And do my focus thing here. So 2 down, 3 to go. That. And that. And all that. Whoops. Okay. All right, so that's test 1 and 2. Test 3. So here's the test itself. If you don't want to look for it, move this over there. Again, ignore the red stuff. This was 5, negative 4, 9, you might recall. Wrapped around 5, negative 4, negative 9. Okay. There's all that. that. Yes, I messed up. Okay, find a domain. Well, it's everywhere where the denominator is not 0. So x squared plus y squared equals 16 is thrown out. So a dotted circle of radius 4 at the origin and shade everything else, everything inside, everything outside, and throw out the circle center of the origin with a radius of 4. Number 2, show that the limit doesn't exist. Pick 2 paths along y equals 0. Limit as x, y approaches 0, 0 of x squared over x squared plus y squared is x squared over x squared, which is 1. So the limit is 1. But if I come along x equals 0, I get 0 over 0 plus y squared, which is 0. I get 2 different limits along 2 different paths. Therefore, the limit doesn't exist. Okay, number 3, find all the second partials. Fx, 3x squared y squared minus 9x squared y to the 4th. Fy is 2x cubed y minus 12x cubed y cubed. Fxx, 6xy squared minus 18xy to the 4th. Fyy, 2x cubed minus 36x cubed y squared. Fxy, which is the same as fyx, 6x squared y minus 36x squared y cubed. And just to double check, you can see if fyx does match, and it does match. Number 4, fx, derivative with respect to x is negative 2x. Derivative with respect to y is 2y. Plug in 5, negative 4, which means x is 5. Fx is negative 10. Fy at 5, negative 4, plug in negative 4, negative 8. So z minus a minus 9 equals negative 10 times x minus 5 minus 8 times y plus 4 by formula. You can leave it like that, or if you want to clean it up, 10x plus 8y plus z equals 9. Number 5, dw dt is the partial of w with respect to x times dx dt plus partial of w with respect to y dy dt plus the partial of w with respect to z dz dt. Okay, and w is x e to the y z to the negative 1. So dw dt is partial with respect to x is e to the y over z times dx dt 3t squared. Partial with respect to y, x over z e to the y over z times dy dt, which is negative 1. And then partial with respect to z is negative x y over z squared e to the y over z times dz dt, which is 6. Number 6, dy dx by formula is negative fx over fy. So fx is 2x plus 3y. Fy is 3x plus 3y squared. That's all there is to it. Number 7, unit normal vector is negative 4, 7 divided by its magnitude. Square root of negative 4 squared is 16. 7 squared is 49. Negative 4 is 7 over radical 65. Del f, the gradient vector, is fx fy. 2 radical y. 2x times 1/2 y to the negative half, or 2 radical y, x over radical y. And the gradient vector at 2, 3, plug in 2 and 3, 2 radical 3, 2 over radical 3. So now the derivative of f in the direction of u, del f dot u. So dot product, 2 radical 3, 2 over radical 3, dot negative 4 over radical 65, 7 over radical 65, which is negative 8 times the square root of 3 over 65 plus 14 over radical 195. I'll accept it if you stop here, because if you go on, you might mess up like me. But I finally fixed it. Multiply top and bottom by radical 3. It comes out nice. It's negative 8 times 3 is 24 plus 14. So negative 10 over radical 195 is the best way to write the answer. And let me do my focusing job on that, so you can see that a little bit better. That also. Whoops. See that there. And yeah, 8 I messed up. So I tried to fix it here. Okay, 8. So find a maximum rate of change of the function at negative 4, 2, 1. So I find a gradient. Comes out to be 1 negative z over y squared 1 over y. F of x, y, z is x plus z over y, zy negative 1. And del f at negative 4, 2, negative 1. So I plug in 1 negative z over y squared is negative of negative 1/4, or 1/4, and 1 over y is 1/2. So 1 1/4 1/2. Okay, so the maximum rate of change is the magnitude of the vector 1, 1/4, 1/2, which is the square root of 1 squared plus 1/4 squared plus 1/2 squared, which comes out to be radical 21/4. And the direction is the direction of the gradient vector 1, 1/4, 1/2. Okay, or if you want to make it look nice with integers 4, 1, 2. Okay, number 9. Find local max, min, and saddle points. F of xy is x squared plus y squared plus xy squared plus 1. Fx is 2x plus y squared. Fy is 2y plus 2xy, which factors into 2y times 1 plus x. Fxx is 2. Fyy is 2 plus 2x. Fxy is 2y. So the D is fxx fyy minus fxy squared. Comes out to be 4 plus 4x minus 4y squared. Okay, so if I set Fy equal to 0, that means y is 0 or x is -1. If y equals 0, plug back in here. In order for this to be 0, that means x is 0. So I have the origin. If x is -1, plug in -1, that means y is plus or minus radical 2. Okay, so my critical points are the origin and -1 plus or minus radical 2. Okay, so the D at 0, 0 is 4. That's greater than 0. Okay, then by formula, I need fxx, which is -2, which means I have a minimum. So f of 0, 0 is 1 is a minimum. The D at -1 plus or minus radical 2, either plus or negative radical 2, you get the same thing when you plug into the D. It comes out to be 4 minus 4 minus 4 times 2, less than 0. So they are saddle points. Okay, so final answer, f of -1 plus or minus radical 2 is 0. Those are saddle points. F of 0, 0 is 1. That's a minimum. Okay, and let me show you this. And this. Okay, and finally, the last one, number 10. Find the maximum and minimum subject to the constraints. So del F equals lambda del G. Negative YZ, negative XZ, negative XY equals lambda 6x 4y 2z. Okay. So that means negative YZ equals 6x lambda, negative XZ equals 4y lambda, negative XY equals 2z lambda. And a nice trick is to multiply both sides of this by x, this one by y, this one by z. That way, all three of these are negative XYZ, which now forces these all to be equal. Okay, so how can that happen? Well, lambda can be 0, or 6x squared equals 4y squared equals 2z squared, or 3x squared equals 2y squared equals z squared. Now, if lambda equals 0, look at these equations. That forces either x, y, or z to be 0, which means f of x, y, z is 0. Okay, this was the original function. So if any one of them is 0, then the function value is 0. We're going to get a positive, we're going to get a negative, so that's not going to be maximum min. Now, if you plug into the original, you get z squared plus z squared plus z squared equals 6, 3z squared equals 6, z squared is 2, z is plus or minus radical 2. Okay, and that means 2y squared equals 2, y squared is 1, y is plus or minus 1. 3x squared equals 2, x squared is 2/3, x equals plus or minus radical 2/3. So I have plus or minus radical 2/3, plus or minus 1, plus or minus radical 2. So how do I maximize? Well, maximize the original function was negative xyz. So I'll get a maximum if all three are negative, or any combination of 1 negative and 2 positive. So maximum is f of negative radical 2/3, -1, negative radical 2 is 2 over radical 3, or any combo of 1 negative and 2 positive. Minimum occurs if they're all positive, f of radical 2/3, 1, radical 2, which is -2 over radical 3, or any combo of 1 positive and 2 negatives. Okay, so that's question 10. Let me go ahead and show that to you. And there we go. Okay, 3 down and 2 to go. Quickly check the chat. Was there anything else? Nothing extra in the chat. Okay, so let me just keep going then. except that I messed up over here. So bear with me just a minute. Paper's organized. Okay, test number 4. So let me just go down the left side and the right side. And again, ignore my quickie solutions on the right side there. Number 1. So here's the box. Okay, 0, 2 cross 0, 3. X equals 1, y equals 1, y equals 2. So I got squares, and they want me to pick the midpoints. So the midpoints are 1/2, 1/2, 3 halves, 1/2, 1/2, 3 halves, 3 halves, 3 halves, 1/2, 5 halves, 3 halves, 5 halves. So our approximation to the double integral of 2x plus dy dA is 1 dA, areas are all 1, and then the function values at all the midpoints. Okay, so I plug into 2x plus 3y. Okay, so if you plug that in, it's 1 plus 1.5. Plug that in, 3 plus 1.5. Plug that in, plug into that, 1 plus 4.5. Plug that in, 3 plus 4.5. Plug that in, 1 plus 7.5. Plug that in, 3 plus 7.5. Final answer is 39. Okay. And I believe, I'm not sure about this, but I think if you actually integrate, the answer was 39. But I'm not positive in that. It doesn't really matter for this problem. Okay, number 2, a simple double integral. So integral of sine is negative cosine y cosine x. Y equals 0 to pi over 2. Take out the negative. Plug in pi over 2, you get 0. Plug in 1, you get 1. So I'm factoring out a 1, which means forget about it. Integral of cosine is sine from 0 to pi over 2. 1 minus 0, 1. 3, double integral. So dy, integrate with respect to y. 3xy plus y squared. Y goes from 0, x squared. Plug in 0, you get 0. Plug in x squared for y. I get 3x cubed plus x squared, x to the 4th. So 3x to the 4th over 4 plus x to the 5th over 5 from 0 to 1. Plug in 0, you get 0. Plug in 1, 3/4 plus 1/5, 19 over 20. Okay, number 4, the hardest part is to get the region. So 0, 2, 3, 2, and 1, 1. This is y equals negative x plus 2. Slope is negative 1. Y-intercept is 2. But you want x as a function of y, so x equals 2y. Okay, these two, slope is 1/2. And then at y minus y1 equals m times x minus x1. But I want to solve for x. Multiply by 2. Do a little bit of algebra. X equals 2y minus 1. So type 2 function, integral as x goes from 2 minus y to 2y minus 1, lower, upper of y squared dx dy. This thing doesn't depend on x, so it's just y squared times the length of the interval. So y squared times 2y minus 1 minus parentheses 2 minus y. That comes out to be 3y minus 3. And multiply out 3y cubed minus 3y squared dy. 3y to the 4th over 4 minus y cubed. Plug in 2, you get 12 minus 8. Plug in 1, you get 3/4 minus 1. 4 minus a minus 1/4, 17 over 4. Number 5, radius is 2. So r equals 0 to 2. Theta goes from 0 to 2 pi. You're integrating x, which is r cosine theta times r dr d theta. R squared cosine theta dr d theta. R cubed over 3. R equals 0 to 2 cosine theta d theta. Plug in 0, you get 0. Plug in 2, you get 8/3. Integral from 0 to 2 pi of cosine theta d theta is automatically 0. Okay, you can just remember what the graph of cosine looks like. For one period, there's as much region above as below. Or if you want to just work it out, integral of cosine is sine. Sine of 2 pi is 0, minus sine of 0 is 0, so it's 0. Okay, number 6, y equals radical 1 minus x squared from 0 to 1. Okay, Integration is e to the x squared plus y squared, which is e to the r squared. Then in polar coordinates, it's r dr d theta. If I do a u substitution, u equals r squared, the derivative is 2r, so I need a 2 here and a half here. Let's see, this expression does not depend on theta, so take out the theta interval, which is pi over 2, and there's a half outside. So I'm integrating e to the u, which is e to the u or e to the r squared from 0 to 1. Pi over 4, plug in 1, e to the 1, plug in 0, 1. So pi over 4, e minus 1. And that's it for this. And there is this. And this. Okay. Then 7 through 10. All right. So the original integrate with respect to y. There is no y, so just 6xz times the length of the interval, which is z, x plus z. So 6xz, x plus z. So 6x squared z plus 6xz squared. Integrate with respect to x, 2x cubed z plus 3x squared z squared from 0 to z. Plug in 0, you get 0. Plug in z, 2z to the 4th plus 3z to the 4th, which is 5z to the 4th. Integrate z to the 5th from 0 to 1, 1 minus 0, or 1. Okay, number 8. I guess I label number 8. Okay, 1, 0, 0, 0, 2, 0, 0, 0, 3. Okay, the best way to find the equation of the plane quickly is to go ax plus by plus cz equals the least common multiple of 1, 2, and 3, which is 6. And you plug in 1, 0, 0. 1, 0, 0 means a is 6. 0, 2, 0 means 2b is 6, b is 3. 0, 0, 3 means 3c is 6, c is 2. So 6x plus 3y plus 2z equals 6. A little bit of algebra. Z is 6 minus 6x minus 3y divided by 2. So z is going from 0 to that. Now I need to analyze the xy plane. So in the xy plane, I look at this, where this is the point 0, 2. That's the point 1, 0. So do your algebra. The slope is negative 2. Y-intercept is 2. That's y equals negative 2x plus 2, or 2 minus 2x, starting at 0. So z goes from 0 to that. Y goes from 0 to that. And x goes from 0 to 1. So here we are. Volume is the integral from 0 to 1. Y goes from 0 to 2 minus 2x. Z goes from 0 to 3 minus 3x minus 3 times y of dz, dy, dx. 9, cylindrical coordinates. X squared plus y squared is r squared, whose square root is r. And then r dz, dr, d theta after that. Okay, so r times r dz, dr, d theta. This thing doesn't depend on z. Take it outside. 5 minus a minus 3 is 8. This doesn't depend on theta. So take out 2 pi. Integral of r squared dr. So it's 16 pi r cubed over 3. Plug in 0, you get 0. Plug in 5, 125. 2,000 pi over 3. And finally, number 10. This is rho squared. And then times rho squared sine phi, d rho, d theta, d phi. Rho goes from 0 to 2. Theta goes from 0 to 2 pi. Watch out, phi only goes from 0 to pi, you might recall. Okay. So rho squared times rho squared sine phi, d rho, d theta, d phi. Rho goes from 0 to 2, theta from 0 to 2 pi. Phi goes from 0 to pi. Okay, this thing doesn't depend on theta. Take outside the length of theta's interval, 2 pi. Rho to the 4th sine phi. Rho to the 5th over 5 sine phi. Rho goes from 0 to 2. Plug in 0, you get 0. Plug in 2. 2 pi times 32 over pi. Integral from 0 to pi of sine phi d phi. 64 pi times negative cosine phi from 0 to pi. Put the negative sign here. Plug in pi. Cosine of pi is negative 1. Minus cosine of 0 is 1. 128 pi over 5. Okay, it's our normal break time, 7 o'clock, but I've done 4. Let's just get it over with, okay? So I will keep going, no break. Let me just go to the 5th exam, and then I'll be done unless anybody has any questions, so we won't break. So there is all of that. And all that. Okay, so 4 tests down, 1 to go. The most recent one should be freshest in your memory. So yeah, if you just want to review by looking at the video, that's good enough. Roughly 3 questions each. Okay, so the most recent exam. Yes, you can see I messed up a couple times. Okay, so YJ, yeah, unfortunately threw off a lot of people. Okay, J means you're only going left and right, and it's proportional to Y. So if Y is 1, the vector is J. If Y is 2, 2J. 3 is 3J. Negative 1 is negative J. Negative 2 is negative 2J. So your arrows are all going left and right. The closer you are to the origin, the smaller they are. The further away you get, and the bigger they are. So that's what it looks like. Okay, number 2, xy cubed. There's x, there's y cubed. 81 sine t cosine cube t. I need ds, which is dx dt squared plus dy dt squared plus dz dt squared dt. 3 cosine t squared, negative 3 sine t squared plus 4 squared. 9 cosine squared t plus 9 sine squared t, that's 9. 9 plus 16 is 25. Square root of 25 is 5, so it's 5 dt. So I'm integrating from 0 to pi over 2. 81 sine t cosine cube t times 5 dt. Take out the 81 times 5, which is 405. Use substitution, let u be cosine. Du is negative sine, so negative 1 inside, negative 1 outside. Negative 405 u cubed, so u to the 4th over 4, cosine 4t over 4. Negative 405 over 4. Cosine pi over 2 is 0. Cosine of 0 is 1. Cube it, it's still 0 minus 1. 405 over 4. Number 3, f is x squared y cubed, negative y radical x. Okay, if I plug in x is t squared squared, negative t cubed cubed, negative y, negative t cubed, radical t squared, negative t to the 13th, t to the 4th. Then dr, which is the same as r prime, 2t, negative 3t squared. Take the dot product, f dot dr, negative t to the 13th, t to the 4th, dot 2t, negative 3t squared. Comes out to be this. So the integral along C of f dot dr, work done, is the integral of negative 2t to the 14th minus 3t to the 6th, negative 2t to the 15th over 15 minus 3t to the 7th over 7. Plug in 0, you get 0. Plug in 1, it's negative 2 15ths minus 3 7ths. A little bit of arithmetic, negative 59 over 105. Number 4, partial of p with respect to y is 5. Partial of q with respect to x is 5. Therefore, f is conservative. That means fx is 6x plus 5y. Integrate with respect to x. fxy is 3x squared plus 5xy plus a function of y, g of y. Differentiate this with respect to y. Fy is fx plus g prime of y. Set it equal to 5x plus 4y. That means g prime of y is 4y, which means g of y is 2y squared plus k. So f of xy is 3x squared plus 5xy plus 2y squared plus a constant. Yeah, the problem says give a function, so you can just lose the k. So this is the anti-gradient. It's very easy to double check that fx is that and fy is that. Okay, number 5, find anti-gradient. So fx is this, you're pretty much doing the same thing. So f of xy is 1/4 x to the 4th y to the 4th plus g of y. Now I differentiate with respect to y, x to the 4th y cubed plus g prime of y is equal to x to the 4th y cubed. That forces this to be 0, which means g prime of y is a constant. So f of xy is 1/4 x to the fourth y to the fourth plus a constant. It's easiest to use k of 0. So f of xy is 1/4 x to the fourth y to the fourth. Okay, so I plug in t as 0, I get 0, 1. Plug in t as 4, 2, 65. So the integral along f dot dr is f of 2, 65 minus f of 0, 1. F of 0, 1 is 0. F of 2, 65, I messed up. So 71,402,500 is what it should be. Okay. Do my focusing thing. And there we go. And yeah, I messed up again, but here we go. Okay, 6. It was much easier to use Green's theorem do the right-hand side. Okay, the left-hand side, if you got it right, I gave it to you, but it's a lot easier to use Green's theorem. So integral of p dx plus q dy by Green's theorem is partial of q with respect to x, 2xy cubed, minus the partial of p with respect to y, which is x dy dx. So the picture is 0, 0, 1, 0, 1, 2. So this is y equals 2x. So in the integration, y goes from 0 to 2x, x goes from 0 to 1. So 2xy to the fourth over 4 minus xy. Y goes from 0 to 2x. Plug in 0, you get 0. Plug in 2x. X times 2x to the fourth power divided by 2 minus x times 2x. 8x to the fifth minus 2x squared. Integrate 8x to the 6 over 6 minus 2x cubed over 3. Plug in 0, you get 0. Plug in 1, 4/3 minus 2/3, 2/3. 7, I messed up. So the curl of f is ijk, partial with respect to x, y, and z. E to the x cosine y, e to the x sine y, 2z. So the I component is nothing minus nothing. J component is the opposite of nothing minus nothing. The k component, at first I thought it was nothing, but I messed up. It was a double negative. It's e to the x sine y minus a minus e to the x sine y. So 2 e to the x sine y k. And I messed up the divergence also. Del dot f, partial of p with respect to x, e to the x cosine y. Partial of q with respect to y, e to the x cosine y. Partial of r with respect to z was 2. So 2 e to the x cosine y plus 2. Okay, 8. U plus v equals 2. U minus v equals 0 from the given data. So 2u equals 2, u equals 1. That means v equals 1. So u equals 1, v equals 1. Okay, you have to solve for that. They give me the point, but I set u plus v equal to 2 from x, u minus v equal to 0 from y, and I get that. Okay, so r sub u, differential with respect to u, 1, 6, 1. Differential with respect to v, 1, 0, negative 1. Take the cross product, I, j, k, 1, 6, u, 1, 1, 0, negative 1. I component is negative 6u minus nothing. J component is the opposite of negative 1 minus 1. K component is nothing minus 6u. So negative 6u to negative 6u. Plug in u equals 1, v equals 1. So a normal vector is negative 6 to negative 6. Okay, that is a normal vector. You're allowed to pick any normal vector that's a scalar multiple. So I decided to pick negative 1/2 times that, which is 3, negative 1, 3. So 3, negative 1, 3. So 3x minus y plus 3z equals k. At the point 2, 3, 0, plug in 2, 3, 0, you get k is 3. So 3x minus y plus 3z equals 3. Okay. And let's see, somebody just joined. Okay, that's fine. Okay, number 9. So 1, 0, 0, 0, 1, 0, 0, 0, 1. Again, you go ax plus by plus cz equals the least common multiple of 1, 1, and 1. Well, that's 1. So if you plug in 1, 0, 0, 1, 0, 0, a is 1. 0, 1, 0, b is 1. 0, 0, 1, c is 1. So x plus y plus z equals 1. It's the equation of the plane. Okay, so a normal vector is 1, 1, 1 divided by square root of 1 plus 1 plus 1, radical 3. Okay, curl f, I, j, k, partial with respect to x, y, and z, x plus y squared, y plus z squared, z plus x squared. So I component is nothing minus 2z. J component is the opposite of 2x minus nothing. K component is nothing minus 2y. So negative 2x, negative 2x, negative 2y. Okay. I decided to show you this extra. You didn't have to do this, but a nice way to find ds is the formula for the area of an equilateral triangle, which is s squared radical 3 over 4. So each of these length is radical 2. So radical 2 squared, radical 3 over 4, radical 3 over 2. So the area of the equilateral triangle is radical 3 over 2. Okay, so area is s squared radical 3 over 4 for an equilateral triangle. All right, so double integral of curl f dot ds, double integral of curl f dot n ds. So curl f dot unit vector. Okay, so if we do the dot product, it's negative 2z minus 2x minus 2y dot 1, 1, 1 over radical 3. Okay, and then times ds, which we know is radical 3 over 2. So I factor out the negative 2, x plus y plus z, but x plus y plus z is equal to 1. So negative 2 over radical 3 times radical 3 over 2, negative 1. And finally, number 10, and then we're done, folks. Okay, so if anybody has a question, you can ask it or unmute yourself. Otherwise, we're finished and just prepare for the final exam. So integral of f dot ds, we don't want to do those 6 surfaces. Okay. And no, I won't make you do 6 surfaces on the final exam. Use a divergence theorem. You don't want to do this. A lot better to do divergence of f dv. So div f, partial of p with respect to x came out to be 0. Partial of q with respect to y is 9x squared z squared. Partial of r with respect to z is 0. So I'm just going to integrate 9x squared z squared. Very nice. Okay, negative 1 to 1 for all of them. I went in the order of dy, dx, dz because this thing doesn't involve y. So just 9x squared z squared times the length of the y interval. 9 comes out times 2. Then I integrate with respect to x. So x cubed over 3 z squared. X goes from negative 1 to 1. Apply the 1/3 to the 9 times 2, 18 times 1/3. Okay. Plug in 1, you get 1. Plug in negative 1, you have 1 minus a negative 1. Okay, so all of this is 6 times 2 or 12. Negative 1 to 1, z squared, z cubed over 3. 12 divided by 3 is 4. 1 minus a negative 1, 4 times 2 is 8. And that is that. Okay, so we're just about done, folks. Anybody join late, go ahead and put your name in the chat. Don't worry, I'll send the video. And yeah, you can get by with just studying this video. My mistakes and all. You have this there. Okay. I really want to say you really don't have to worry a whole lot about stuff. If you mess up, you did some calculation wrong, don't worry. You know, I'll give you partial credit. I messed up a lot. And dare I say, there were some of you in this class that made fewer mistakes than I did on the exam. Okay, and that is it, folks. So I've shown you all the exams. That's it. Don't look at the text book anymore. You don't have to. Don't look at the homework. Just look at the exams in preparation for the final. Okay, so any other last questions? Otherwise, we're done. Let me check the chat. Okay, so I'll get to Lucas, Elliot, Jerry, Amy, Nicholas Trapanis, and Nicholas Chan. I got you both. Carl, Rashan, and Andrea. I think I have all of you. Okay, so congratulations on passing Calc 3. Just have a final exam left on Thursday, and that's about it. So any other questions, please, before we call it an evening? Leave the chat on, wait for a moment that you ask anything. All right, I don't see anything, I don't hear anything. All right, so good night, everybody, and we'll see you for one last meeting for the final exam on Thursday. Okay, all right, so bye, everybody. Have a good night.
Thank you.
Bye.
Thank you.
Thank you.
Good night.
Thank you.